So what would the type rules for let and where look like? Let's first look at the type rule for a let expression. So given some type environment E, how can we type let x be E1 in E? What's the type of that? Well, to type check this, we must first type check E1. So if E1 has the type T1 in our type environment, then we can type the body E in our type environment, where we have added now the assumption that X has type T1 because X here must have the same type as its definition E1. So given that, we can then type the body E, and if that E has type T, then the whole let expression gets type T. So that's the let rule. Now the where rule is very, very similar to that. What does a where declaration look like? It says that Y is declared to be E, where then inside E we can talk about X, which we define to be E1. And what's the type of that? Well, to find that, we must find the type of E1, and if that E1 has type T1, then we can type the body of the declaration, now with the added assumption that X has type T1, and if the body E then has type T, then that's the type of the whole declaration. So the let and where type rules really are very similar. There's something that is very useful if you want to structure a Haskell program nicely, and that's the notion of local declarations. And local declarations occur in two forms. First, let me present where declarations. Where declarations are local declarations that are part of some other declaration. Let me give you an example. First, we'll try to write this without using wheres, and then we'll use a where declaration to make this a little more readable. Suppose I declared the factorial function fac of 0 being equal to 1, fac of n being n times fac of n minus 1. And then I suppose I wanted to use the factorial function to compute binomial coefficients. So the binomial coefficient of n and q, what's that? Well, that's the factorial of n divided by the factorial of n minus q times the factorial of q. So we could write everything in that way. But suppose the only place we ever want to use the factorial function is inside the definition of binom, then it's a bit silly. It would be nicer if we could simply write fac as a local function. We would write where, and then we would write it in here. And let's try to do that. Let's simply take this and put it here. Bit of indentation. Let's give this to Haskell. Haskell's happy. Now we can call binom. With 7 and 2 we should get 21. Oh yes, we did. Can we call fac of 7? Nope, because fac is not in scope. Fac is only known inside binom. So when we have local declaration that we only want to use inside another declaration, then we can use the where, and where should be placed after the declaration. But here's another kind of local declaration, and that's the idea of having let declarations. We can also have let declarations, and the let declaration happens inside an expression. Suppose we want to define the binomial coefficient function slightly differently. We'll call it binom prime of n q, and then we would want to have the factorial function available to it. So let's declare it globally here. So now anyone can use it. Maybe we should have a bit of indentation here, or less indentation rather. Then we could use a let declaration to separate the computation of the numerator, which is fac of n, and the denominator, which is fac of n minus q times fac of q. And then we write let that in numerator divided by denominator. Let's give this to Haskell. Haskell's happy. And what is the binom prime of 7, 2? Hopefully it's 21. And look, it is 21. So these are two kinds of local declarations that we can use: where declarations and let declarations. And my message to you is, please use them to structure your program. Please, please, please use them. The next question is, how do we type check expressions and declarations that contain wheres and lets? Let's have a look at that now.